Good morning, students. In this session, we are going to discuss about the Portland cement and its manufacturing process. Course outcome. Exploring the chemistry behind the technology of building materials is a major course outcome of this session and learning outcome. At the end of the session, student will be able to understand OPC and its chemical composition. The meaning of OPC is ordinary Portland cement. And student will be able to gain the knowledge of OPC manufacturing process and steps involved in it. Introduction. Portland cement. It's a common type of cement in general use around the world as a basic ingredient of concrete, mortar, stucco and non-specialty grout. It was developed from other types of hydraulic lime in England in the early 19th century by Joseph Aspdin and usually originates from limestone. The most common called ordinary Portland cement is grey, but white Portland cement is also available. Its name is derived from similar to Portland stone, which was quarried on the Isle of Portland in Dorset, England. It was named by Joseph Aspdin, who obtained a patent for it in 1824. However, his son William Aspdin is regarded as the inventor of modern Portland cement due to its development in the 1840s. So, history recording the Portland cement is used by the Egyptian in creating their pyramids in 138 AD and used volcanic tuff mixed with lime to produce cement by Greeks and Romans. Castle di San Angelo in Rome, stripped away for 100 years. In 1769, making of natural cement was learned and demonstrated by a diversion dam in San Diego, California. In 1824, Joseph Aspdin, a British stonemason, obtained a patent for Portland cement by calcination of argillaceous limestone called Portland because the concrete made resembles a famous building stone obtained from the Isle of Portland near England. These are the basic histories regarding the Portland cements. Now let us have a discussion regarding the definition of OPC. Cement can be defined as bonding materials having a cohesive and adhesive property which makes it capable of unite the different construction materials such as aggregates, cores, water, and it acts as a binding agents and forms a compact assembly. Ordinary or normal Portland cement is one of the most widely used type of Portland cement. This type of cement used in construction where there is no exposure to sulfates in the soil or groundwater. Lime saturation factor is limited between 0.66 to 1.02% and free lime causes cement to be unsound. Percentage of aluminum oxide, iron oxide is not less than 0.66%. Insoluble residue not more than 1.5%. Percentage of sulfur trioxide limited by 2.5%, where C3A should be less than 7% and not more than 3%. The expansion of C3A is nothing but calcium trisilicates. Loss of ignition, that is 4% maximum. Percentage of magnesium oxide should be 0.5%. Fineness not less than 2250 cm square per gram. Manufacturing of OPC. What are the basic raw materials required for the manufacturing of OPC? Calcareous material and argillaceous material. Supplies lime to cement. Limestone should be 65 to 80%. Chemically, it is nothing but calcium carbonate. Marl, chalk, shale, calcite, alkali waste. It should contain less than 3.3% of magnesium oxides and 3 to 4% of silicon dioxide, iron oxide, and aluminum oxide combined together. Argillaceous material supplies silica, alumina, and iron oxides. Clay, marl, shale, blast furnace slag, sand, etc. Here silica provides strength, alumina imparts quick setting, iron provides color, strength and hardness. So each and every chemical composition in argillaceous material plays a different role of OPC cements. And gypsum increases setting time. So gypsum role is very, very important in OPC. And power coal and fuel oil for generating required temperature. So all these things is the major raw material for the manufacturing process of OPC. Okay. Normally this manufacturing process involves two types. One is wet process, another one is dry process. In this session, we are going to discuss in detail regarding the wet process, and moreover, wet process predominantly using in the market when compared to the dry process. When you compare the basic ingredients of both the process, that is dry and wet, are almost same. By mass, lime and silica make up approximately 85% of Portland cement. The materials that are commonly used are limestone, shells, chalk, shale, clay, slate, silica, sand, and iron ore in both the process. Since limestone is a major component, often cement plants are located near limestone quarries because the major raw material itself limestone. So instead of doing a separate process of extracting the limestone and getting into the manufacturing unit is quite difficult. So we are installing the manufacturing unit near to the limestone quarries. And almost crushing reduces the size of rock to then 3 inches or smaller. And the raw materials are combined the correct amount and fed in the kiln system almost in both the process. But in dry process, the materials are ground, mixed and introduced into the kiln system in a dry state. That is the major difference between the dry and wet process. Almost remaining thing is same. All the raw material before feeding into the kiln should be dry. And they are grinding the material and ensuring whether the moisture content is there or not. Later only they are getting into the process of kiln system. Okay, let us have a discussion in detail regarding the wet process. The steps involved in wet process are: number one, crushing and grinding of raw materials, because the big lumps are crushed and grinded into fine particles or small lumps. Number two, mixing the materials in a proper proportions. Number three, heating the prepared mixture in a rotary kiln. Number four, grinding the heated products known as clinker. Number five, mixing the grinding of cement clinkers with gypsum. These are the 5 stages involved in wet process. Let us have in detail regarding the wet process. Crushing and grinding. In this phase, soft raw materials are first cut into suitable size. Because the raw materials are available for the cement manufacturing process and each and everything should be in different size. So we have to make it as a homogeneous form. So we are crushing and make it in the fine particles. This is done usually in cylindrical ball or tube mill containing the charge of steel balls. Number two, mixing the materials. In this part, the powdered limestone, that is a major raw material for the process, mixed with the clay paste in proper proportion. That is 75% of lime and 25% of clay. And the mixture is then grounded and made homogeneous by means of compressed gas. And the resulting material is known as slurry, having 35 to 40% of water. So at the end of the mixing process, we have to ensure whether the slurry is having this 35 to 40% of water. Then that is the desired quality of that mixed materials. Number three, heating the slurry in rotary kiln. So stage 1 is crushing over, and stage 2 we mix almost all the raw material, that is limestone and the clay, and we achieve the moisture content of desired specification, that is 35 to 40%. And the third stage we are charging those material. That is why this process is known as wet process, because we are charging the material having 35 to 40% of water content, moisture content. Whereas in the dry process, this material should be in a dry condition. It should be free from moisture. Here, we are introducing a slurry into the rotary kiln with the help of conveyor. The rotary kiln consists of large cylinders of 8 to 15 feet in diameter and height of 300 to 500 feet. It is made with steel and usually lined with the fire bricks. And the kiln rotates at a rate of 1 to 2 revolutions per minute. In rotary kiln, slurry is passed through different zones of temperature. Between the kiln itself, some variation of temperature will be there. This whole process skill usually covers 2 to 3 hours. Different temperature zone are as discussed in the diagram itself. Number 1 is preheating zone. Normally this kiln will segregate into the three compartments: preheating, decomposition zone, burning zone, cooling zone. In the preheating zone, temperature is kept at 500 degrees Celsius and usually the moisture is removed first and clay is broken into silica, aluminum oxide and iron oxides. Clay is a composition of silica, aluminum oxide and iron. So once we remove the moisture, the clay becomes dry and it gets segregated into individual chemical constituent. The next stage is decomposition zone. Temperature is raised to 800 degrees. From 500 it is raised to 800 degrees Celsius. So in this zone, limestone decomposes into lime and carbon dioxide. So whereas in preheating zone, clay moisture is getting removed and clay is breaking into individual constituent. Next, the temperatures rise from 500 to 800 degrees Celsius. At this stage, the limestone breaks and converted to lime and carbon dioxide. Next stage is burning zone. In this zone, the temperature is maintained and rise to 1500 degrees Celsius from 800. And the oxides formed in above zones combine together and form respective silicates, aluminates, and ferrites. Next is cooling zone. From 1500, we are dropping the temperature to 150 to 200 degrees Celsius. At this stage, the material whatever formed at the final stage of cooling zone is known as clinker material or cement clinker. And it is usually in the form of greenish black or grey colored balls, sometimes dry materials. And finally, we are grinding the clinkers with the gypsum. Here, the quantity of gypsum is important. The required amount of gypsum usually is 5%, is ground to the fine powder and then mixed with the clinker. And final cement is packed in bags and then transferred to the required site. So, of all the process, in the manufacturing of wet OPC by wet process, the very, very important region is the rotary kiln region. Because each and every stage of varying temperature, each and every process is carrying out. The first temperature, as we discussed earlier, clay is getting decomposed. In the second stage, limestone is getting decomposed. In the third stage, everything is get converted into the form of silicate, aluminates and ferrites. And finally, in the cooling zone, we are collecting all the materials and make it to dry to around 150 to 200 degrees Celsius. And finally, we are grinding with the gypsum and packing to the desired site. Here I highlighted the process flow of OPC manufacturing. So this is the lime quarry from where we are breaking the limestones and discharging into the loader. From the loader, we are transferring to the dumper. From the dumper, we are switching to the crushing zone. Here all the lumps of limestone are crushing into fine particles by the mechanical crusher. And from there it is transferred to the raw mill through the conveyor belt. And from here it transferred to the preheating zones. And next to the rotary kiln having a various temperature compartment. And at the final stage of the rotary kiln is the cooling zone. Here we are maintaining the temperature of 150 to 200 degrees Celsius. And whatever material we obtained here, it's a clinker material or cement clinker. And this cement clinker we are collecting and we are treating it the gypsum of 5%. Once we are mixing the gypsum with the clinker, we are grinding the whole material to get the finished product. And from there we are distributing in bags. And finally we are dispatching into the desired sites. This is the overall flow chart of the synthesizing OPC by wet process. Again, the major difference between the wet and dry lies only in the preheating area. Here we are charging the material having 35 to 40% moisture content in wet process, whereas in dry we are totally drying the material and we are ensuring whether it's free from moisture. And that's all about the manufacturing process of OPC by wet process. Thank you.